Alright class, in this video we're going to go over the steps of the scientific method. Scientific method is a useful technique that scientists and even problem solvers in other fields will use in order to solve everyday situations. So what is the scientific method? It's actually a logical problem-solving technique. Logic means that there has to be steps involved that make sense, and problem solving is a way to solve a problem. One of the first things I ask new students when they come to my class is, let's say you lost your keys and you're looking for your keys. Write down the steps you take to find your keys. You're essentially doing the same thing as a scientific method in order to make a logical way to solve the problem. Maybe you backtrack your steps. Maybe you go to where you normally drop your keys off when you get home. And those are all logical ways to look for your keys. Alright, here are the steps of the scientific method. First, you want to make some observations about the world around you using your senses. From that, you're going to develop a problem statement, that is the statement that you're trying to solve. From this, you're going to make a hypothesis. It's an educated guess on what you think will happen, changing your variables. From that, you want to do your experiment and also collect your data to prove your hypothesis. And finally, you make your conclusion statement on what you studied and your results of your experiment. Scientific method has to begin with observations. Observations have to be a visible or provable fact. A lot of times people and scientists will even make inferences. Now that's an opinion or conclusion based on the facts. Inferences is what we want to stray away from when we're studying science. So here I have one of the Far Side cartoons, one of my favorite cartoon series. You could see in the picture it says, "My word." That one just came too close for comfort, if you ask me. A few observations. You want very obvious facts here. An observation you could say is, there are 2 fish. Right? You could also say there is 1 human. These are observations you could make. An inference is essentially what you predict is going to happen maybe a few seconds later. So inference, you could say the human is thirsty because he is spreading his hands out to try to get the fish. That is still an inference. You don't know that as a fact. Maybe he was just tired. Once you have observations about the world around you, you want to make a problem statement. Problem statement has to compare variables. Variables are things that change in an experiment. So for example, will the bounce height affect the drop height of a super ball? Let's say I have a bouncy ball over here, and then I drop it. What if I drop the ball at a lower height? Will that affect the amount that it bounces? You might make a good hypothesis based on this, but the problem statement will just say this question. From here, you want to know the difference between a dependent and an independent variable. Independent variable changes unrelated to other factors. We change them on purpose. The way to remember it is independent variables, the variable we know before we start the experiment. If you know that you're changing the drop heights, then that'll be the independent variable in the drop height bounce height lab. We will know the drop heights we will use. Maybe you pick 1 meter high, then 2 meters high, and so on. A dependent variable is a variable that changes depending on something else, usually the independent variable. Key way to remember it, dependent is a variable we do not know before we start the experiment. It has to happen during or after the experiment when you collect your data. So we will not know the bounce height before we start. We will know the drop heights though. So the bounce height depends on the drop height of the ball. Next, you have a constant. Constants do not change for the duration of experiment. One of the hardest parts of experiments is making sure all the other variables are constant except your independent and dependent variable. So for instance, you will not want to change the type of ball in this experiment. If you change the type of ball, then you have another variable which you could actually test in a separate experiment, but make sure that you keep only your dependent and independent variables what you're testing. From this, to make a hypothesis statement is an educated guess on what's going to happen. It's what you think the results will show. A really good way to write your hypothesis statements is with an if, then, because statement. So for example, if a super ball is dropped from increasing heights, then the bounce heights will also increase because so-and-so. Notice I wrote if a super ball. The part right here says is dropped from increasing heights. That'll be my independent variable. Then the bounce heights will also increase. Bounce heights will also increase is the dependent variable. Easy way to write an hypothesis. If, state your independent variable. Then state your dependent variable. Because, give a reason. So because on this one could be if I increase the potential energy from different heights, then the bounce should be higher because it's a bigger transfer of energy. I also made a video on potential kinetic energy if you're interested in the physics playlist on my YouTube page. Next, you want to conduct your experiment. Experiment is a planned way to test your hypothesis and find your answer to the problem statement. You want to test only the problem statement and not other variables. Your experiment will compare your independent variable to the dependent variable only. And important, only test one variable at a time. It's very hard to make an experiment with only dependent and independent variables. Everything else has to be a constant as close as you can. From here, we're going to make a conclusion statement that presents the findings of the experiment, what the data shows, and also state if your hypothesis was correct or incorrect. A good way to start a conclusion would be, based on the results of the experiment, my hypothesis was, you say either correct or incorrect, because, and then give reasons why. Use your data to support or negate your hypothesis. When you're looking at data, the many different types of relationships, the most common types are direct. That's when one goes up, the other goes up. This data here shows the GPA of freshmen at the University of Maryland. You can see how the GPA has been increasing over time. You also have indirect relationships. Indirect is when one goes up, the other goes down. This chart shows labor and leisure choice. Obviously, you only have 24 hours in a day, so you could either be having fun, having leisure, or working. As you work more and more, your leisure time will go down. As you're working less and less, your labor time will go down. Last relationship is constant. That means as one increases, the other relatively stays the same. This shows fuel price projections and how much money oil will be. You see that most of these lines are relatively constant. Alright class, so this concludes our video. If you have any questions, feel free to leave a comment down below and shoot me a message.